Hi guys, this is my part 2 video to the chapter 2 motion chapter, motion. And so we finished last video talking about speed, and I'm just going to give you a little reference here. If just refresh your memory, speed is equal to distance over time, so it is a rate, and speed is also a scalar quantity, scalar q, because it only has magnitude only, right? If you need a refresher on scalar and vector quantities, go and watch my scalar and vector quantity video. But now we're going to move on to two different branches of speed, one being instantaneous instantaneous speed, and then the other being average speed. Okay, so I'm going to give some nice definitions for these two. Okay, so under instantaneous speed, basically what you want to think of is the speed, the speed at any one given instant. Hence the name instantaneous speed, right? Instant. So if I have a car down here, and right now, so here's the road, and right now he's going 30. Let's forget the units right now for simplicity of I'm running out of time. I mean, sorry, not time, space here. So let's just say he's going 30 miles per hour here in this time frame, but then in the next minute, he hits a stop sign here, right? Stop sign, and he's going 0. You know, intuition will tell you that. And then let's say he starts going after the stop sign. It's another break in time. Stops going. He starts going again after the stop sign. There's a little bit of traffic, so let's say he's going 15, right? So then the instantaneous speed is the speed, like if I were to check the speedometer on the car at this instant, right here, this instant, it would say 30 miles per hour, right? But if I were to check it at this instant when I'm at the stoplight, it would say 0. Then here it would say 15. And anywhere in between that, me changing from 30 to 0 to 15, that's called acceleration, which we'll talk about later, but it's also um, at any instant in between here, I will have a different speed on the speedometer because I'm decelerating and then I'm accelerating. So that's instantaneous speed, the speed at any given instant. Now, average speed is different, much different actually. Average speed is, let's say we have this trip, okay? We have 30 miles per hour, but then in another frame of time, we have 0. Then in another frame of time, we have 15. Well, I want to know, let's say that this, actually, you know what? Actually, that's not the best example for average speed because something you need to know about average speed is that it uses the same equation as the general speed equation that we talked about before, which is the speed is distance divided by time because it's a rate, you know. So now I'm gonna uh, fast forward a little bit. So with average speed, the equation is still speed is equal to, well, it's a little, the thing you need to kind of notice now is it's total distance over time interval. There's really no difference with those words, no difference from the total distance, the regular speed equation. So it's kind of basically the same equation, but what you need to think about, let's say you have a trip, okay? I'm going to section off a little area over here. Let's say we have a car trip, right? And my family's going on a car trip. And we go in the first, so let's say the total car trip is 10 miles. Or let's make it 100 miles, right? But then, and let's say it's supposed to take us, let's say we're going from San Francisco to LA, I'll use that analogy again. Let's say it's going to take us 8 hours, right? 8 hours, okay? Now to find the average speed, obviously, within this time, I'm going to hit traffic, red lights, stop lights, or just stretch the freeway where we accelerate. So at one point in time, I could be going 100 miles per hour. But then at another point in time, I could be going 5 miles per hour. Now these are both instantaneous speeds. Those are the speeds that I'm going at any given instant. But how do I get the overall, my average speed, the average speed it took us to complete this 100-mile journey? Well, that's simple. Just plug in your distance here and your time here, and you'll get, when you divide it out, you will get your average speed. Average speed, right? That's the average speed throughout the whole journey, because you're taking the total distance and the total time interval of that distance. So that's how you find average speed. Now the next subject that we're going to talk about is velocity, which is actually a very important one, probably the most important in this whole chapter, next to acceleration. So we have velocity, okay? And now velocity, two things to notice. Velocity is often interchanged with speed in everyday speaking. So velocity, but what you have to notice, velocity often equals speed in everyday speaking, but in science does not equal speed, because velocity is a vector quantity and speed is a scalar, right? Is a scalar. So now that we have that in mind, let's talk about what velocity is, right? So velocity is speed in any given direction, d. So the equation is still the same. Velocity is distance over time, but then with your answer you must give a direction, right? Distance over time. So let's say I'm going from San Francisco to LA. That's southbound. So I take that whole trip again, right? That was bad, but I take that whole trip, that 100-mile trip that I complete in 8 hours. 8 hours, right? Here's the road. That 100-mile trip that I complete in 8 hours. My velocity is this resulting average speed, the resulting average speed with a direction, right? With a direction, because velocity is a vector quantity. So you always need to have this directional component here. So that's very important about velocity. Now there's also, like with speed, there's two branches of velocity that are important to know. So the first being constant velocity. I like that color. Constant velocity, and the next being changing velocity. Now, in everyday life, you're not going to see constant velocity very much, because the prerequisites for constant velocity are you need to have a constant speed and a constant direction, right? So a car turning the corner like this, let's say the car's going in a circle like this, okay? It's just going in a circular path. So let's say it has a constant, it's never going above or below 30 miles per hour, which is unrealistic because of many different, human causes. But let's say it has a constant, ideally it has a constant speed of 30 miles per hour. But the problem is, this is not a constant direction. Here it's going this way. See, here it's going this way, here it's going this way, here it's going this way, here it's going this way. So that is not constant velocity because the direction is changing. Constant velocity is if I have a straight line. It has to be exactly straight, which this is not. But constant velocity is talking exactly straight line with exactly constant speed always. So when you think constant velocity, you think straight line, always, okay? Now let's move to changing velocity, okay? So changing velocity would be like this example, because it's changing its direction or it's changing its speed. So if we have the car going in the circle, and let's say here he's going let's say here he's going 20, here he's going 30, here he's going 15, right? At this section of the circle he's going 15. So he's changing both D and S, direction and speed. But it could be either. It can be, he could change direction only or speed only. It doesn't matter. Changing velocity means either speed, S or D, is changing, or both. either one of those has to be changing for changing velocity to occur. So that is the more common one in everyday life because you have stoplights in cars and whatnot. So